welcome back to our channel. And our topic for today is about diagrams of off-the-grid smart houses or simple smart house. Okay, so this is how your sustainable off-the-grid house would look. It has a low maintenance and long-lasting sliding materials right here, and thick insulation wall, triple glazed windows. That's the kind of glass that is triple glazed so that the heat of the sun cannot enter 100% of the heat into your interior. Same with the insulator in the thick insulation of your walls. Also, your smart house will have energy efficient heating system, geothermal energy right here, on-site food production. Of course, you need a space to plant for veggies, and most important is your off-the-grid power, the solar energy panels. Also, you have your green roof for added plants, rainwater collector system right here, and energy storage, some kind of chargeable battery, and your wastewater treatment. Now let's look for other diagrams for your off-the-grid smart house. So you need to maximize the energy available, the solar energy. So the angle of your panel must facing the east, especially in summer time. The angle of the panel is so important to absorb more energy or heat energy from the sun. You must have also a wind generator in case your solar panel will not work. You have your wind generator as a replacement. And right here are batteries. These are DC to AC converter. You have your rain collector here, and also watering the plants coming from the gray water in your house. Right here we have the sink, which the gray water will enter and will be fed into your plants. Okay, so this is a good diagram for your off-the-grid simple house design. Let's go to the other diagram. Okay, here it is. This is solar hot water here, multi-glazed windows. Here are some solar panels that will generate more energy, the wind generator and the rainwater collector. So this is a simple diagram for a simple small off-the-grid house. Okay, sustainable features. What are these? Just maximize the summer sun at the high angle during summer, but in the winter, sun is low in angle. So you have to plant trees beside your house. It will help reduce heat and also will resist against winds. So number one, opening at high level to induce stack effect. You use green roof here. Number two, you have plants here, vegetables, whatever it is that you can cook. Number three, potential to add solar collectors right there. Also, you need underfloor heating during winter time. In the Western Hemisphere, of course, it is cold during winter, but in the Philippines we have only two types of climate, that is rainy and the sunny. Number 5, building envelope with high thermal performance, right here, and shading from trees. Okay, other diagram for the energy efficient house. Here it is. You must have a LED lightings. LED or LED is much more give lights than incandescent bulb, and it only uses low energy compared to the traditional bulbs. Right here, the turbine, the wind energy, solar panels, and never forget the rainwater collector, because you're off the grid, of course. There is no commercial water that will be tapped into your house. Water is very much important next to lights. So you need also a energy heating cooling system, and you must recycle water. So how it is to live off the grid, away from the city, away from the convenience of your life. Alright, hang on guys for a while. Coming up will be an discussion about the 4 elements of sustainable design that you can use to maximize efficient energy or to maximize the design of your sustainable homes. Our topic for today is about elements of design of a sustainable building. Okay, these are the elements: the sun, sky, air, water, and earth shape the nature of architecture which emerges on this site. The use of the sun or the natural heating or lightings. The passive solar design is an important feature in the design of this building. The planning and orientation of the spaces and building blocks ensures glare-free daylight in all regularly occupied spaces. All the linear blocks are oriented in the east-west directions with shorter facades facing the sun. Another element of a green sustainable design is the usage of natural air. The predominant wind direction is taken into account in designing the open spaces. The central atrium acts as an air funnel defined by the other buildings. The opening oriented in the prevailing wind direction catches the outside air and channelizes it through a narrow stretch of the block before releasing it into the central court area. Sky, okay, is another element of a sustainable design. Maximum use of daylight and use of light sensors to regulate the use of artificial lighting in the interiors is another key design strategy. In areas where daylight is available, fixtures have been fitted with continuous dimming electronic ballast. These fixtures are controlled by light sensors which respond to available light conditions and automatically regulate the connected fixtures to achieve the desired level of uniform illumination required. In cooperation with water-saving fixtures, the rainwater harvesting was an important concern in the design brief from very beginning. Okay, the rainwater harvesting is the key to minimize the use of commercialized water supplies. Water and waste management system are important features of the building design. All buildings in the campus have been provided with low-flow fixtures such as dual flush, low-flow taps, and sensor taps that result in 25% saving in water use. Rainwater harvesting is also an important concept which contributes to efficient water management. The average annual rainfall of Delhi, India, rainwater runoff from roof and the site are tapped to recharge the aquifer. This enhances the sustainable yield in areas where overdevelopment has depleted the aquifer. The excess surface water is also conserved and stored for future requirements. The Earth. The campus is equipped with three types of cooling system: variable refrigerant volume system, Earth Air Tunnel, the EAT, and thermal mass storage, the VRB, is proposed for peripheral commercial block and administrative block of the institute. The use of Earth Tunnel gives an energy saving of nearly 50% as compared to the conventional system. So thermal mass storage used for cooling the classrooms and labs involve storing energy when available and using it when required. Here, cooling of thermal mass is done during night. This cold thermal mass is used to cool air. In daytime, this system gives an energy saving up to 40%. Number one is to integrate functionality of building with energy application. 2. Minimize energy demand in the building through architectural intervention. Number 3. Meet the space conditioning and lighting demands through energy efficient system. To meet the electric energy demands using renewable energy sources. Solar lights used in gardens, solar street lights. Few of the south-facing walls are mounted with aero screen louvers fixed at an angle of 35 degrees. This ensures that the winter sun is let in whereas the summer sun is blocked. The use of louvers in front of glazed walls also reduces the heating up of the glass facade considerably. The Earth Air Tunnel is used in the hostel blocks. This is a dual heating cooling system using the heat sink property of the earth to maintain comfortable temperatures inside the building. Air which passes through the buried pipes get cooled in the summer and heated up in the winter. A lot of research went into the design of this system. Airtron, the air conditioning consultants for the project collaboration with Faculty of Indian Institute, the Bangalore simulated the system and refined it to perfection. Design features: for roof insulated with vermiculite concrete and China mosaic white finish. Insulated walls using expanded polystyrene insulation. Shading devices and fenestration have been designed to cut off summer sun and let in winter sun. Glare-free daylight use through specially designed skylights. Energy efficient system EAT. 4 tunnels of 70 meter long and 70 centimeter diameter laid at the depth of 4 meters. 4 fans of 2 horsepower. Each force the air into the solar chimney for the air out of the rooms. So here it is, guys, the diagram for the Earth Air Tunnel. So in winters, temperature recorded was 22 degrees when the ambient temperature was 10 degrees Celsius. Energy efficient lighting uses energy efficient compact fluorescent lamps in residential quarters, corridors, lobby, and toilets. The conference rooms enjoy glare-free daylight through the skylight. Wastewater is recycled by root zone technique, in which the root of the Phragmites plants with several special capabilities of collecting the waste of the roots are used to clean the water which is used for irrigation. It cleans 5 meter cube of water every day. water harvesting and watershed management are proposed in entire area. The photovoltaic panels or the solar panels, solar water heater taps the sun energy directly. A series of photovoltaic panels capture the energy and store it by charging a bank of batteries. A number of panels, each measuring 1.1 by 1.2 meters, are joined and form an integral part of roofing and building. The panels can generate up to 10.7 kilowatts peak of energy, which is fed into 900 ampere per hour 240 volt battery bank. Here are some basic energy sources in the eco-friendly building complex. Using the sky for daylighting heatsink, sun for heating, electricity generation daylighting, greenhouse effect solar chimneys, and air ventilation heatsink, earth roof gardens, earth berms for insulation, water roof ponds, fountains for humidification, rainwater harvesting. Here are some details of the solar chimney in the building. The sun rays hit the black south wall, increasing temperature of immediate environment around. This causes the air in the cavity to rise upward naturally. These convectional currents are blown away by the winds, blowing south to north. This creates a vacuum at the top core structures. To fill this vacuum, air from inside is drawn up. The system of hot air rising and drawing the cool fresh air is a continuous process. The building has been designed with landscape at various levels. These courts help to enliven the working environment as well as enhance the microclimate within the structure. As thermal capacity of the earth is high and an annual temperature fluctuation keep decreasing with increasing depth of earth. At depth of 4 meters below ground, temperature remains constant and equal to annual average temperature of earth berm is created to retain the heat. Conclusion: building conveys skillful interplay of natural elements with the building form to reduce energy demand. And thank you so much guys for viewing the videos, and don't forget to subscribe and make a lot of comments for your attendance right here in our YouTube channel, The Art Lover Millennials. Ciao for now.